morning, everyone. So today we're doing Chapter 4 review, which there's a handout for on Teams, which you should print off and fill in as you watch this. So the first section is exponent rules. We're going to go through just some of the concepts that you learned in this chapter and then do some examples and just let me know if you have any questions. So we learned 6 exponent rules. So first, the product law. The product law is that if I have two numbers with the same base and I'm multiplying them together, I can add their exponents. So this would be, I would do 3 to the power of 6, sorry, that was negative 7, plus negative 7 equals 3 to the power of negative 1. The quotient law is that if I'm dividing two numbers with the same base, I can subtract their exponents. So if I have x to the power of 7 divided by x to the power of 2, that would be x to the power of 7 minus 2, which would be x to the power of 5. The power of a power law says that when I have a number with a power and it's all to another power, I multiply the two powers. So it would be 4 to the power of 2 times 3, which is 4 to the power of 6. Another example of this would be 2x squared, all to the power of 5. And in this case, it's important to note that the 5 goes to the 2 and the x squared. So now I have 2 to the power of 5 times x squared to the power of 5. So that's 2 times 5 is 10. And similarly, I have a over 3 squared all to the power of 4. Now the a is to the power of 4 and the 3 squared is to the power of 4. So that's a to the power of 4 over, 3 to the power of 8. All right, the zero exponent law says that when I have any number to the power of 0, it's equal to 1. The negative exponent law, if I have 2/3 to the power of negative 1, the negative exponent tells me to use the reciprocal, so it would be 3 over 2, and now it's to the power of positive 1. So we switch the fraction, or we do the reciprocal, and then that power becomes positive. And then the rational exponent law is x to the power of m over n equals the nth root of x to the power of m. So for example, 9 to the power of 3 over 2, that would be the square root of 9 all cubed, equals the square root of 9 is 3, cubed is 27. All right, some examples. So we're going to simplify and solve. So m cubed times m squared equals 3,125. So I'm multiplying these m's together, which means I can add their exponents. So that leaves me with m to the power of 5 equals 3,125. Now to solve for m, I'll need to take the 5th root of both sides. So now m equals, and then on your calculator you would do the 5th root of 3,125, m equals 5. B, m to the power of 7 divided by m to the power of 6, all squared equals 196. So for this one, I could use the division rule because I have m divided by m. I'll subtract their exponents, so 7 minus 6 is 1. So I'm left with m to the power of 1 squared equals 196, which leaves me with m squared equals 196. So I'll take the square root of both sides. M equals the square root of 196 is 14. And don't forget that it could be positive or negative 14. All right, C. 1/16 to the power of 1/4 minus the cubed root of 8 over 27 equals the square root of x squared. So 1/16 to the power of 1/4 is the same as the 4th root of 1 over the 4th root of 16 minus the cubed root of 8 over the cubed root of 27 equals the square root of x squared. The square root cancels out the squared, so this is just x. All right, the 4th root of 1 is 1. The 4th root of 16 is 2. The 3rd root of 8 is 2, and the 3rd root of 27 is 3. So now I have 1/2 minus 2/3 equals x. So in order to subtract fractions, I need a common denominator, which would be 6. So 3/6 minus 4/6 equals x. Negative 1/6 equals x. Okay, D. H to the power of 5 over 2 divided by the 6th root of h to the power of 3, all to the power of 4, equals 256. So the square root of h, sorry, we're not going to do that root. We are going to put the denominator into a fraction. So now I have h to the power of 3 over 6, all to the power of 4, equals 256. Now I'm going to apply this 4 to each power. So that would be h to the power of 5 over 2 times 4 equals 20 over 2, which equals 10. And then 3 over 6 times 4 equals 12 over 6, which equals 2. So h to the power of 2 equals 256. Now I can subtract the exponents on the h's because of the division rule. So 10 minus 2 is 8. So h to the power of 8 equals 256. I'll take the 8th root of both sides. And I'm left with h equals 2. E. 64 times f to the power of 6 times g to the power of negative 3, all to the power of 1/3, times 81 times f to the power of negative 4 times g to the power of 8, all to the power of 1/2 equals 288. So the first thing I'm going to do is apply the power of a power rule. So to every term inside the bracket. So I'll have 64 to the power of 1/3 times f to the power of 6 times 1/3, which is 6 over 3, which is 2, times g to the power of negative 3 times 1/3, which is negative 3 over 3, which is negative 1, times 81 to the power of 1/2, times f to the power of negative 4 times 1/2, which is negative 4 over 2, times g to the power of 8 times 1/2, which is 8 over 2. So 64 to the power of 1/3 is the same as the cubed root of 64, times f squared times g to the power of negative 1, times 81 to the power of 1/2 is the same as the square root of 81. F to the power of negative 4 over 2 is f to the power of negative 2, and g to the power of 8 over 2 is g to the power of 4. The cubed root of 64 is 4. And then I can add the exponents on the f's together because I'm multiplying, and I can add the exponents on the g's together because I'm multiplying. So f to the power of 2 plus negative 2, and g to the power of negative 1 plus 4. And then all we have left is the square root of 81, which is 9. All right, so I have 4 times 9 is 36. F to the power of 2 plus negative 2 is f to the power of 0. And then g to the power of negative 1 plus 4 is 3. So now f to the power of 0 is the same as 1. So I'm left with 36 times g to the power of 3 equals 288. Divide both sides by 36. g to the power of 3 equals 8. Take the cube root of both sides, and g equals 2. All right, next page. Transforming exponential functions. So, transformations come in the form of f of x equals a times b to the power of k times x minus d plus c, where a, k, d, and c are the same a, k, d, and c that we've learned in the past. B is the base. If b is greater than 1, there's exponential growth. If b is between 0 and 1, there's exponential decay. So growth would look like this, and decay would look like this. So to graph these transformations, you can use the table of values from the parent function, and you can use general mapping to help transform the graph, or you can do one transformation at a time. So you could do the a value, and then the k, and then the d, and then the c. So let's just recall general mapping for a minute. So that was when you took a point and you plugged in the a, k, c, and d values to transform that particular point. So you would do x over k plus d, comma, ay plus c. So let's do an example. So if I have f of x equals negative 1/2 times 3 to the power of x plus 1, all plus 2, then my a value is negative 1/2. My k value is not there, which means it's 1. My d value is negative 1, because remember the original equation here is negative d. And my c value is 2. The parent function here is, since its base is 3, the parent function is f of x equals 3 to the power of x. And those are just the transformations that have happened to it. All right, so we're going to make a table of values for the parent function. So I have x and y. So this is f of x equals 3 to the power of x. So just choose a range of x values. I'm going to go from negative 3 to positive 3. And then just plug these x values into this equation, 3 to the power of x, to get your y values. So I have 3 to the power of negative 3 equals 1 over 3 cubed equals 1 over 27. 3 to the power of negative 2 equals 1 over 3 squared, which is 1/9. 3 to the power of negative 1 equals 1/3. 3 to the power of 0, anything to the power of 0 equals 1. 3 to the power of 1 equals 3. 3 squared equals 9. And 3 cubed equals 27. So these are my points. Negative 3, 1 over 27. Negative 2, 1/9. Negative 1, 1/3. 0, 1, 1, 3, 2, 9, 3, 27. So then I would draw that on the graph, plot those points, and that's my parent function. Now to do the transformations, I would use general mapping, which is x over k plus d, ay plus c. So x over k is 1, d is negative 1, a is negative 1/2, and c is 2. So that's my general mapping. So for the first point there, I would have x over 1, so I'm not going to write the 1. X minus 1, sorry, x was negative 3. So negative 3 minus 1, negative 1/2 times 1/27 plus 2. So I just plugged in x and y. And now my new point is negative 3 minus 1 is negative 4. Negative 1 times negative 1/27 plus 2 is 1.98. So my point went from negative 3, comma 1/27 to negative 4, comma 1.98. So I'll do the next one. I have negative 2 minus 1, negative 1/2 times 1/9 plus 2 equals negative 3. That would be negative 1 over 18 plus 2, which is positive 1.94. So that's the second one there. And then so on. So you would continue to do these, and these are the numbers that you will get. Negative 2, 1.83. Negative 1, 1.5. 0, 0.5. 1, negative 2.5. And then the last one is 2, negative 11.5. So this is kind of a mess, but I can put up a picture of mine in a second. So I'm going to plot the points on the graph, and then you'll be able to see the difference between the parent function and the transformed function. So just pause the video for a minute and draw your graph, and then in a second my graph and table of values will be up. All right, so here's my table of values and my graph. So this graph here is the parent function, and then this one is the transformed function, just by plotting those points from my table of values. All right, moving on to applications of exponential functions. So the general form for exponential functions is f of x equals a times b to the power of x. A is the initial value, your starting value. B is your rate of growth. That's if b is greater than 1, or your rate of decay, and that's when b is between 0 and 1. And remember, you calculate your growth rate by doing b minus 1 times 100%, and you calculate your decay rate by doing 1 minus b times 100%. All right, x represents the number of growth or decay periods. And f of x, or y, represents the amount after x time has elapsed. All right, and then there were three formulas that you learned that could be used in your application questions. So the first one was compound interest. And that one was a equals p times 1 plus I to the power of n, where a was the final amount, p was the principal original amount, I is the interest rate in decimal form, and n is the number of compounding periods. I will give you these formulas on the test as you need them, so you do not need to memorize them. The second one is doubling growth. And that one is a equals a0 times 2 to the power of t over d, where a is the end amount, a0 is the original or initial amount, t is the time, and D is the doubling period. Remember that they need to be in the same units. So if one is in days and one is in weeks, get them both into days. And the third one is the half-life formula. And that is A equals A0 times 1/2 to the power of T over H, where A is the end amount, A0 is the original amount, T is the number of half-life periods, and H is the half-life period length. Again, T and H will be in the same units. All right, and then the last thing that's important, which we briefly talked about, but I just want to show you again, was that a table of values can be used to calculate the base, or B, using a ratio of first differences. So if the question says, here's a table of values, or they just give you some numbers and they say find the base, you can do that using the first differences. So it's not equal to the first differences, but I will show you. We have X and Y, and then we'll have the first differences. And then we'll have the ratio. So for X, I have 2, 3, 4, 5, and 6. For Y, I'm given this information, 0.64, 0.512, 0.4096, 0.32768, and 0.262144. Okay, now the first differences here. You do the second number minus the first number. So it would be negative 0.128, negative 0.1024, negative 0.08192, and negative 0.065536. Okay, and now we're going to look at the ratio. So there's not really a connection in the first differences, it doesn't look like. But then the ratio, we're going to do the second number divided by the first number. So negative 0.1024 divided by negative 0.128, and that equals 0.8. Then we're going to do negative 0.08192 divided by negative 0.1024. That also equals 0.8. And negative 0.065536 divided by negative 0.08192 also equals 0.8. So that means that the base is 8. Or sorry, 0.8. The base is 0.8. Okay, so find the first differences, find the ratio, or divide to see what you're multiplying by each time. So basically, I'm multiplying by 0.8 each time, right, in the first differences, and that is the base. Okay, so there's some suggested review questions listed there. Work on the ones that you struggle with the most, and post your questions on teams that you don't understand. Post them right away, because the test is tomorrow at 9. So if you post them right away, I'll try to post solutions right away, or maybe get a video up if more people have questions. But let me know as soon as you need them, okay? Have a good day, and I'll talk to you soon.